Okay, so Kepler's second law is actually equivalent to saying that R cross V equals constant, equals a constant vector. Okay? That's what the law says. So in terms of derivatives, it means d by dt of R cross V is the zero vector. Okay? Now, so there's an interesting thing to know, which is that we can use the usual product rule for derivatives with vector expressions, with dot products or cross products. There's only one catch, which is that when we differentiate a cross product, we have to be careful that the guy on the left stays on the left, the guy on the right stays on the right. Okay, so if you know uv prime equals u prime v plus uv prime, then you're safe. If you know it as u prime v plus v prime u, then you're not safe. Okay, so that's the only thing to watch for. So product rule is okay for taking the derivative of a dot product. There you don't actually even need to be very careful about the order of things, or derivative of a cross product. There you just need to be a little bit more careful. Okay, so now that we know that, we can write this as dr dt cross v plus r cross dv dt. Okay? Well, let's reformulate things slightly. So dr dt already has a name, in fact. That's v. Okay? That's what we call the velocity vector. So this is v cross v plus r cross, what is dv dt? That's the acceleration, a, equals 0. Okay, so now what's the next step? Well, we know what v cross v is, because remember, a vector across itself is always 0. Okay, so this is the same as r cross a equals 0, and that's the same as saying that the cross product of two vectors is 0 exactly when the parallelogram that they form has no area. And the way in which that happens is if they're actually parallel to each other. So that means the acceleration is parallel to the position. Okay? So in fact, what Kepler's second law says is that the acceleration is parallel to the position vector. And since we know that acceleration is caused by a force, that's equivalent to the fact that the gravitational force is parallel to the position vector. That means, well, if you have the sun here at the origin, and if you have your planet, well, the gravitational force caused by the sun should go along this line. In fact, the law doesn't even say whether it's going towards the sun or away from the sun. Well, what we know now is that, of course, the attraction is towards the sun. But Kepler's law would also be true, actually, if things were going away. So in particular, say, electric force also has this property of being towards the central charge. So actually, if you look at motion of charged particles in an electric field caused by a point charged particle, it also satisfies Kepler's law, satisfies the same law. Okay, that's the end for today. Thanks.